Okay, pre-lesson for 2-2. It's the only day we're going to take to cover 2-2. It's just one day. But there's quite a bit coming at you. A lot of algebra. So every little thing that I say here in this pre-lesson is going to be significant. I'm not just trying to waste your time. This stuff is going to be intricate and detail-oriented, so pay attention to this stuff. And here we go. So, quick review. You've been doing this. What is the vertex of this parabola? Well, by now, we look at that, we say, hey, that's 1 to the right. So that's 1, and that would bump it up to 3. Hopefully, that is just like, oh, yeah, we've been doing that. But this stuff isn't going away. But that's not my point today. My point is more algebra-ish. I want you to notice something. It is always y equals, and then it looks like this, or f of x equals this. You guys are getting used to that format. It's kind of like y equals mx plus b, y equals mx plus b. You've seen it forever. But what I want to point out to you is it's never 1/2 y or 2y. The y is always isolated, alone. Same with the f of x. So what's the problem with this? Well, if this is the way it was, we'd have to multiply everything by 2 to get it where we wanted it to be. So we'd have to multiply that by 2. So we distribute. We get y equals 2 times x minus 1 squared plus 4. We say, so there's a vertical stretch, right 1, and then a 4. Because y is isolated, we can now read where our vertex is. With that in mind, we're going to dig a little deeper now. The question I'm asking is, where does the x minus 1 squared from this come from? Like, what is it really? Well, it's going to take you back to your algebra days. I know it was 2 years ago during COVID, and a lot of you might have cheated your way through it because it was all online. Just being real in the 616. So if I say, hey, square this binomial, it would look like this. And this is where you guys, and I'm sure you've been taught this, would FOIL this thing out. So x times x is x squared. Outside would be negative 1x. Inside, negative 1x. Negative 1 would be 1. And then if I added all those like terms together right here, I would get x squared minus 2x plus 1. What is this? Well, this is actually called a perfect square trinomial. I nickname them, because it's trying to get your attention. Because if you see something like this, you're like, hey, you know what? That's a perfect square trinomial. Pause. 49 is a perfect square because we can write it as 7 times 7. 64 can be written 8 times 8. 100 can be written 10 times 10. Now, where does this perfect square come from? It means that if I had the area of a square was 100, both of my sides could be 10. They're perfect whole numbers. That's why they're called perfect squares. Now, let's take it back to this. If I factored this, remember the days of factoring trinomials? So we're doing things in reverse. Here, we multiplied this all out, and we end up getting this. Now, what if we factored this? Again, like 28 can be factored into 7 times 4. These are considered factors. This is not a perfect square, but these are factors. So let's factor this out. So we go like this. We know because this is x squared, this would be an x and an x. What are two factors of this number that add up to this? It'd be negative 1 and negative 1. So I put a negative 1 there and a negative 1 there. Notice these are the same. So this trinomial right here is considered a perfect square trinomial. Keep that in mind. Because when you factor it, you end up getting two binomials that are the same. And then you can write it like this. And then if it's written like this, and it's in a quadratic equation, you can then tell that it's bumped to the right one. That's why it's so important. As you can tell, we're going to be doing some factoring and looking for perfect square trinomials. Let me pause this a minute. Okay, building on what we just talked about. Here's a couple of examples of perfect square trinomials. If you look at this, I want you to notice this is a 1. This is a 1. That's going to be very significant. So the coefficient of your squared term has to be a 1. Keep that in mind, okay? But if we look at this and we say, hey, what's the square root of 9? 3. What's 3 plus 3? 6. So we're like, hey, that means this factors into x plus 3, x plus 3. If you don't believe it, FOIL it out. X squared plus 3x plus 3x, 6x. 3 times 3 is 9. But you want to write it like that. Remember, that's going to tell us that the vertex was bumped left 3. Let's look at this one. So once again, we look at this number and we say, hey, that's a perfect square root. What are two factors of this? 16 that add up to this? Well, that'd be negative 4 times negative 4. We're like, wait a minute. Now, I know 4 times 4 also makes 16, but these do not add up to negative 8, so I can't use those. I got to use negative 4 and negative 4. So that would be x minus 4, which I can write x minus 4 squared. Now notice, this says, what is the vertex of the quadratic equation, blah, 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 blah. Like, wait a minute. I can't tell from this where the vertex is, but I have to say that's a perfect square trinomial. So that factors into x minus 4, which is x minus 4 squared, basically plus 0. So where did this vertex get moved if this is now f of x? This gets moved 4 to the right, and there is no plus or minus d, so that would be 0. There's the vertex. Now, we're going to mix things up a little bit. This is really the meat and potatoes right here. The rest has all been built up with algebra basics. This is going to be like what your homework looks like. What is the vertex of the quadratic diddle-a-diddle-a-do? Well, this is not a perfect square trinomial. In fact, if we even tried to factor this, we'd say, hey, what are two factors of 4 that add up to negative 2? Not going to happen. So factoring it is not even going to work, let alone having a perfect square trinomial. So what do we got to do? We need to use this technique called completing the square. Remember I said a 1 has to be the coefficient of your squared term? That's step number 1. So coefficient of squared term must equal a 1. You go check. So the next thing you're going to do is you're going to bump the constant over, that's an R, and then create 2 spaces. So what's the constant? The constant in this case is the 4. What do you mean bump it over and create 2 spaces? So don't mess with this. Remember I said you don't want 2y, you don't want 1/2 y. That thing's sitting good. So y equals x squared minus 2x. Here comes the space. Bumping the 4 over, and then create another space here. Now, what you're going to do is take half of your middle, I'm going to abbreviate, coefficient, and then square it. First of all, what do you mean middle? Well, I'm picturing this as my trinomial. So there's 1, 2, 3 things, even though there's nothing here, there's going to be. So what's the middle coefficient? It's the negative 2. Don't worry about the x, it's just the coefficient. Take half of that, well that'd be negative 1. What do I do with that? You square it. What are you going to do with this answer? You're going to put that in this space right here. But if I put a 1 on this side that wasn't there originally, I got to keep it balanced by putting the opposite right here. Sort of keeping that equation balanced. That'd be like going like this. 8 minus 7 equals 1. And if I add a 1, if I add a 1 here, now it's not true, so I'd have to make up for it by putting a negative 1. That's all you're doing. You're keeping it true, but you're making it readable now. Why? Because this is a perfect square trinomial. So this is y equals, if I factored that, I'd say, hey, x squared, I need an x and an x. Two factors of positive 1 that add up to negative 2, that's a negative. Be negative 1 and negative 1. I don't want it to look like that. I want it to look like this. And then look at this. We add those together, we get plus 3. And now I can go, aha, the vertex is going to move 1 to the right, and then it's going to go up 3. Now remember, the pre-lesson is to just set the foundation and kind of get you started. So make sure you watch the next video with the sample problems, and you'll get the rhythm of it. Good luck.